In this video, we are looking at behavior of polynomials, and we are going to start with the function here, and this function has a odd degree and the leading coefficient which is positive. So 1 is the leading coefficient, the degree is 5 as the highest exponent, and if I look at this term, the term which is going to have the highest impact on the value of y is the first one because it's raised to power 5. Now let's consider the first question. What happens to the y values as the x values get bigger and bigger? And I look at the values of x as they increase, the y values increase. And you can see I just consider the first term because it will tell me what's going to happen because it has the most impact. And this is how we can be able to write it in limit notation. So the lim is the short form for limit. And limit is like a boundary. So I'm approaching a boundary. But here, what we can say is, as I approach infinity, because you can only approach it, you never get there. So the limit, as you approach infinity, the y values get bigger and bigger, so they approach infinity. And all I'm saying here, on the graph, this is infinity. As I approach infinity for the x values, then the y values are approaching infinity. What about if I do the opposite? Now I plug in smaller values. X values decrease without bound. So I'm going to plug in smaller values of x. And again, you see the values of y get smaller without bound. And you can see as I approach negative infinity, I get negative infinity. And the way I can show that, as x approaches negative infinity, y values approach negative infinity. This will be negative infinity. So this is what happens to the graph at the endpoints. I may not know what is happening in here, but I just want to know what happens at the endpoints. Now let's consider an even function. There's an even function. The degree is even, and the leading coefficient is positive. Again, I'm just going to consider the first term. So I plug in 10, then I plug in 100, and you see the values are getting bigger and bigger. So if I plug in a very big number, I'm going to get a very big number for y. As I approach infinity, I go all the way to the right. So I'm approaching infinity, going in this direction. I see the y values are getting bigger and bigger. And this is how we show that in limit notation. As x approaches infinity, so the limit of f of x approaches infinity. And what about if I plug in small values, negative 10, negative 100? Again, I see because my exponent is even, so the values become positive. And so when I approach negative infinity, here I should have a negative, then I'm still going to get positive infinity. So that means the graph is going to be going up. And again, check the end behavior. This is how we are going to represent that. Okay, now here, let's consider another function. And if you look at this function, I want you to notice that the leading coefficient is negative, but the degree is still even. So what is happening? Again, I take the first term, I plug in 10, I get a negative number because the negative is out here. So even though the exponent is even, I still have the negative. So the numbers get smaller. So that's what I have is when I plug in a big number, I get a very big negative number. And the same thing when I plug in negative 10 and negative 100. As I approach negative infinity, y values become very small, approaching negative infinity. So this is how the behavior is going to be illustrated to the right, and this is how the behavior is illustrated to the left. And again, I can see here both arrows are going down. It's approaching the arrows are pointed down. I want you to notice that when it's even, the arrows are pointed in the same direction. When the leading coefficient is negative, they are pointed down. Leading coefficient is positive, they are pointing up, both of them. Now, a summary of what we have looked at. So consider the leading coefficient is positive, the even degree. Look at the arrows, they are facing both directions. And this is how you describe the head behavior. As x approaches negative infinity, so y approaches infinity. As x approaches positive infinity, and y approaches positive infinity. If the leading coefficient is negative, notice that the arrows are pointed down. So whenever you see a graph and the arrows are pointed down, both of them, the leading coefficient must be negative and the degree must be even. What about the odd? Look at odd. They are facing different directions. If the leading coefficient is positive, going from left to the right, you can see it's going up. When the degree is odd, when you look at the arrows, they are pointed different directions, you know the degree must be odd. When it starts up, then goes down, then you know the leading coefficient must be negative. And you can see the behavior here. So now, given any function, you just need to focus on the leading coefficient and the degree. And the head behavior is going to be summarized, as you can see right here.